everyone. In this video, we'll discuss about the concentration cells. Concentration cells are galvanic cells with the difference that here the two half cells are having the same electrode made up of same metal and they are immersed in the same electrolyte, with the difference that the concentration of the electrolytes in the two half cells are different. In a galvanic cell, the two electrodes are made up of different material and they are immersed in the solution of their own ions. Otherwise, both galvanic cell and concentration cells are same. The two half cells are connected with the help of a salt bridge. So let us now see how the construction and working of a concentration cell takes place. The concentration cells, where both the half cells have the same metal electrode and the electrodes are immersed in the solution of same ions as the metal electrodes, but the concentrations of the electrolytes are different. The electrode which is immersed in a dilute solution of electrolyte becomes the anode, and the one which is immersed in a concentrated solution of ions becomes the cathode. So the flow of electrons is from dilute solution towards the concentrated solution in the external circuit. And the cell representation is given as metal ions with the concentration written, salt bridge with the help of two perpendicular lines, metal ions and its concentration written, and then the metal electrode. Say here if we take a zinc electrode, then we will write the cell representation of zinc concentration cell as Zn, Zn2 plus with the concentration of Zn2 plus ions, salt bridge again Zn2 plus ions and its concentration, and then zinc metal. We can classify the concentration cell into two types: electrolyte concentration cell and electrode concentration cell. In the electrolyte concentration cell, the electrolytes are kept at different concentrations. But in the electrode concentration cell, the electrodes are kept at different pressures. Therefore, the electrodes becomes different. In this video, we will learn the electrolyte concentration cell in detail. So, as I have described, that the electrodes in an electrolyte concentration cell are made up of same metal. They are immersed in the solution of same electrolyte but with the different concentrations. And the flow of the electrons in the external circuit is from dilute towards the concentrated solution. Suppose the anodic compartment solution of the electrolyte is kept at C1, and in the cathodic compartment the electrolyte is at C2 concentration and C2 is greater than C1. Then the cell representation will be M, Mn, C1, salt bridge, Mn, C2, M. The figure here gives the description of the concentration cell in detail. We have taken silver electrodes in both the compartments, and silver nitrate is taken as the electrolyte. In the anodic compartment, the silver nitrate solution is kept at C1 concentration, and in the cathodic compartment it is kept at C2 concentration, and C2 is greater than C1. Both the compartments are connected with the help of a salt bridge, and the flow of the electrons we can see from anodic compartment towards the cathodic compartment, that is from dilute towards the concentrated solution. Cell representation is Ag plus C1, salt bridge, Ag plus C2, that is the concentration of the silver ions in the cathodic compartment, and silver electrode in the cathodic compartment. So whenever we are writing the concentration cell, the concentrations of the electrolyte should be written compulsorily. And the reactions are also shown here. At anode, oxidation takes place with the liberation of electron. At cathode, the electron is accepted from the external circuit and the reduction takes place. So the overall reaction is written here. Calculation of the EMF of the cell is done considering that the C1 is the concentration of the electrolyte in the anodic half cell and C2 is the concentration of the electrolyte in the cathodic half cell at 25 degrees centigrade, and C2 is greater than C1. We can calculate the EMF of the cell E using the Nernst equation by taking the formula E is equal to E naught right minus E naught left. Since we have taken the same electrodes, so E naught M will be same, and therefore cancelling the E naught M on both the sides, we get E is equal to 0.0591 by N log C2 by C1, where E naught M is the standard electrode potential and N is the number of electrons transferred during the reaction. So whenever we are calculating the E cell of a concentration cell, the concentrations should be written, taken into consideration, and the reactions should be written so that we can calculate the number of electrons transferred during the reaction. We can conclude that if C2 is equal to C1, then log C2 by C1 will be 0. And in this case, there will be no generation of electricity. But if C2 by C1 is greater than 1, then log C2 by C1 will be positive, which will result into spontaneous reaction and the electricity will flow. So, higher the ratio of C2 by C1, higher will be the cell potential. The significance of concentration cell is this, that in nature, it is the concentration cells that develops on the surfaces and leads to corrosion. Therefore, concentration cells should be understood and should be read in detail. Thank you.